nggak sih kebayangan aslinya otak? Otak yang enak atau otak yang kayak gini? Inside this brain are countless cells working together, kind of like a neural network. As you saw above, a neural network has three main layers. Three main layers.
Hello, I'm Wahyu as input layer.
Hi, I'm Yana, the hidden layer.
Hey, I'm Ganfi as an output layer.
Alright, Nancy. Now, let's jump right into the material. Think of a neural network as a team of simple decision records called neurons, arranged in layers. The first layers take raw inputs like pixel values of an image or features such as age or test results. Each hidden layer's neurons look at the signals from the previous layers, do a simple calculation, then pass their output on. The final layer gives the answer, say cat versus dog, or score from different classes. During training, the network sees many examples, compare its guesses to the correct answers, measures how far off it was, and adjusts its internal weight to improve over time. Neural networks learn complex patterns without us writing explicit rules, which makes them powerful for tasks like recognizing faces, translating languages, or even predicting health outcomes.
Okay, now I will explain about how does probability appear in neural network. Okay, there are two main ways probability show up. The first one is output probability or softmax. In many classification texts, the network class layer uses a softmax function that turns raw score into number between 0 and 1 that add to 1. Okay, for example, an image classifier might be 0.7 for cat, 0.2 for dog, and the last one 0.1 for rabbit, meaning 70% for cat, 20% for dog, and 10% for rabbit. If one class has a high value exaggerator 0.95, the network is quite confident. If they are closer, exaggerated 0.4 for cat, 0.35 for dog, and the last one 0.25 for rabbit, it's plus 0. Okay, softmax probabilities give a basic sense of confidence, but don't capture uncertainty about the model's own internal setting or how it handles totally new input.
Second is parameter uncertainty, or we usually call it Bayesian approach. Instead of treating each weight as a fixed number, we treat weight as a random variable with distribution. Before seeing a data, we have a prior belief, so its weights likely near to 0 with some spread. After seeing a data, we update to posterior distribution over weight. To predict, we sample many weight settings and see how much the output vary. If most samples agree, we're confident, but if they differ, we are uncertain. Exact computation is too heavy for large network, so we use approximation like variational inference, Monte Carlo network, and Monte Carlo dropout. This gives a more honest estimate of uncertainty, especially when inputs are unusual.
Sometimes it's really hard to understand, isn't it? There are a lot of implementation of probability and neural network, like in this article we use as references. I'll give you an analogy about football match prediction as planning a picnic with uncertain weather. Think of planning a picnic when the weather forecast says 50% sun, 30% light rain, and 20% heavy rain. You may pack a tent or choose an indoor plan. In match forecasting, a neural model might say the team has 50% wind, 30% draw, and 20% loss. Coaches or batters see it's a close call and choose to plan strategies or bet accordingly. The probabilities help prepare for different outcomes rather than acting as if the result is certain.
Now, I will explain about benefits and caution. Using probability in neural networks brings many benefits, such as it shows uncertainty, it helps guide through the test or beam checks, it supports safer decision in medicine or driving, and it can guide experiments or hyperparameter tuning by highlighting where the model is unsure. But there are some cautions, such as getting uncertainty estimates will take more computation, approximation will be more imperfect, and implementation is more complex than a plain network. Oh, and it's also important to check the calibration. If the model says 70%, then it's 70% at the time.
Okay, from our explanation above, we can conclude neural network that know their own uncertainty are safer and smarter. Okay, remember the weather forecast. Knowing the chance of rain help you decide. Next time you see AI prediction, look for its confidence level, that probability in neural network at work. Nah, sudah kebayangkan rasanya otak yang seperti ini? Gimana? Enak gak rasanya? Bahkan, AI pun punya confidence loh dalam pecahin masalah atau problem solving. Nah, semoga apa yang kita sampaikan tadi bisa bermanfaat dan menambah wawasan kalian ya. Guys, sini dong, sini. 1, 2, 3. Boost your confidence more than AI. Bye.